we have different rules to determine the nomenclature, to get the nomenclature of the coordination complexes. If you give the formula, you can, if you get the formula, you can write the name. If you get the name, you can write the structure. Both are possible. Okay, first one, formula for mononuclear coordination entities. Here we are discussing how, if the name is there, how can write the complex. So before that, I am moving to the naming part. Okay, so here the one complex is given. See, here we can see that is PTNH3 4 times Cl2. This is the complex. So how can we name this complex? So the first step I'm telling you here, this things inside the coordination sphere is called coordination sphere, right? That is the coordination part, the coordination sphere, and this chlorine is called ionization sphere. First, we have to determine the charge of coordination sphere and ionization sphere. Suppose here 2 chlorine is there as the anionic part, means that is the ionization sphere. So 1 chlorine, we know they have -1 charge. So here 2 chlorine means there will be 2 minus charge. So the total charge of the ionization sphere is -2. So the total charge of this coordination sphere will be obviously +2. So here the coordination sphere is the cationic part and this chlorine is the anionic part. Okay, now the first rule is, if you you are naming a coordination compound, we have to start from the cationic part. Here the cationic part is the coordination sphere. Okay, now we are leaving this ionization sphere now. First we are going to give the name for the coordination part, because that is the cationic part. Now, in the cationic part, if it is the coordination sphere, means the metal and ligand is there. First, we have to give name for the ligand. So here we have 4 ammonia. So we will write the name, like if 4 is there, we will write like tetra. So here actually it is 6. Okay. So here we have 6 ammonia. So I am writing hexa. But here it is 4 means I will write tetra. Okay, so here it is 4 now. So what will happen? Here I am writing the name. I am starting the name with tetra. So tetra. Now here NH3 ligand is called amine. So we can call it as tetra amine. Now the ligand part is over, right? Now we are moving to the metal, platinum. We can see that the platinum metal is a part of positively charged coordination sphere. So the metal name we can write like metal itself. No need to end the name with AT. If the coordination sphere have a negative charge, the name of the metal should end with AT. That is platinate, cobaltate, like that, ferrate, like that. But here the metal is a part of positively charged coordination sphere, means we can write the name of the metal as itself. So tetraamine, platinum. Now we have to mention the oxidation state of the metal here. So we are using the formula, that is the metal atom I'm taking as X. We have to know the charge of ammonia, that is always 0. So 4 ammonia means 4 into 0. That is equal to total charge of the coordination sphere. So 2 chlorine is outside, means the charge of this complex will be +2. So X plus 4 into 0, that is equal to +2. So X equal to +2 means the oxidation state of metal is +2. So it will be 2. We have to write it in Roman letter. So tetraamine platinum 2. Now the things outside the bracket, that is chlorine, I will write it as chloride. Okay, so this is the name tetraamine platinum 2 chloride. But here the difference is, here inside the square bracket we can see only one ligand is there. This is a homoleptic ligand complex. In case of heteroleptic complex is there, means more than one ligands are there, we have to choose the alphabetic order. Suppose ammonia is there, that is NH3 is there, chlorine is there inside the square bracket. So we have to write the name of amino group first, that is amine first, then chlorine, because A is first, then C. So we have to choose the alphabetical order while naming that one. Okay, so that is the difference. Now see, CONH3 6 times Cl3. We will look at this example. So CONH3 6 times Cl3. First we are going to find out the charge of the complex. So here we have 3 chlorine outside the coordination sphere, right? So the charge of chlorine will be -3 and the charge of the complex will be +3. So the cationic part means it is again the coordination sphere. We have to name this part first. So we are starting from the ligand, that is 6 ligands are there, means we have to write hexa. Now NH3 is the ligand, means hexaamine. Now the metal is cobalt. It is a part of positively charged coordination sphere, so we are writing hexaamine cobalt. Within the bracket the charge of the complex. Now the name of the ionization sphere, chloride. Now we are going to find out the charge. I am taking it as x. X plus ammonia, that is 0. 6 into 0 is equal to plus 3. So x we will get, that is equal to plus 3. So the charge will be plus 3. So this is the name of this complex. Okay. Now here, if you know the name, you can write the structure also. Tetraamine diaqua cobalt 3 chloride, right? So here you can say, in this case, the tetraamine diaqua cobalt 3 means cobalt is the metal, so we are writing it first. Tetraamine means 4 ammonia is there, so NH3 4 times. Now diaqua, see here amino group is one ligand, water is normally called as aqua. So aqua is another ligand. So in case of this one, aqua we have to write first based on the alphabet. So CONH3 4 times. So diaqua means H2O 2 times. Now we are writing CO, cobalt. So tetraamine diaqua cobalt. Okay, so CO we write first, then chlorine. Chlorine is outside. But we don't know how many chlorine atoms are there outside. So we have to find out using this oxidation number. Oxidation state of the metal is given as 3. So we have to find out the charge of the complex. So I am taking as 3. 3 plus. Ammonia have a charge 0. So 4 into 0 plus. Water again have a charge 0. 2 into 0 is equal to, the answer will be 3 again. It means the charge of the complex is 3. Means 3 chlorine will be there outside to maintain the neutrality. If it is 2, 2 chlorine will be there. Because 2 plus means 2 minus will be there. 1 chlorine always have 1 minus charge. This is the way to write the formula if the name is given. Okay. Now, the same way, naming of mononuclear means the same way. How we are writing for the previous one, the same. Means there we know the structure, we are writing the name. Here we are, if you know the name, you can write the formula for the complex, same way.